Imagine a world so extreme it makes our wildest science fiction nightmares look tame. Now picture a planet circling its star so closely, its skies blaze at temperatures hotter than many stars, forging storms and rains of molten metal. What secrets could such a place possibly hold about the birth and fate of planets across our universe? And what did NASA's James Webb Space Telescope just uncover that has astronomers both puzzled and exhilarated? Let's journey nearly 900 light-years away from Earth, to a planet astronomers have nicknamed the Hell Planet. Officially, it's called WASP 121b, and it's unlike anything we've ever seen. WASP 121b is a gas giant, a little more than 1 times the mass of Jupiter, but astonishingly, it's nearly double Jupiter's width. Discovered back in 2016, this alien world orbits its sun at such a blistering pace, just 30 hours per revolution, that if it moved any closer, it would literally be torn apart by the star's gravity. The planet's day side never sees darkness. Temperatures soar to about 5,500 degrees Fahrenheit, or roughly 3,000 degrees Celsius. At this heat, molecules are ripped apart, and metals like iron can vaporize, creating clouds that rain molten droplets. Meanwhile, the perpetual night side is only slightly less unforgiving, hovering around 2,750 degrees Fahrenheit. Violent supersonic winds roar between the two hemispheres, whipping up storms that make even our solar system's wildest hurricanes look like gentle breezes. But what truly sets WASP 121b apart is what's happening in its atmosphere. Using the James Webb Space Telescope's ultra-sensitive instruments, researchers have just spotted something that's never been seen in any planetary sky before: vaporized silicon monoxide. Detecting SiO in WASP 121b's atmosphere is groundbreaking, says astronomer Angeli Piet from the University of Birmingham. It's the first conclusive identification of this molecule in any planetary atmosphere. Silicon monoxide is not supposed to exist as a gas in planetary skies. On Earth, it's only found as a solid, used in solar panels and electronics. In the cosmos, it's sometimes spotted in stars but rarely anywhere else. The intense heat on WASP 121b keeps this exotic molecule in a vaporized state, offering scientists a rare window into the chemistry of worlds pushed to their limits. So, why does this discovery matter? For one, it paints a stunning picture of how violent and unpredictable planet formation can be. Joanna Barstow, an expert in exoplanetary atmospheres, explains, "Studying the chemistry of ultra-hot planets like WASP 121b helps us to understand how gas giant atmospheres work under extreme temperature conditions. The observation of silicon monoxide hints that silicate-rich asteroids, think cosmic rocks packed with minerals, might be burning up in the planet's atmosphere, leaving behind this molecular fingerprint. But not everyone agrees about what these findings mean. Some scientists believe this could reshape our understanding of how gas giants migrate and evolve, especially those living on the edge of destruction. Others wonder if we're just scratching the surface of what's truly possible when we look at planets beyond our solar system. Here's where things get even stranger. WASP 121b is not only roasting in its orbit, it's also shedding its atmosphere, forming a massive comet-like tail as gases escape into space. The planet is losing material at a staggering rate, and yet the powerful mixing of its skies keeps rare molecules like silicon monoxide suspended above the inferno. With the James Webb Space Telescope opening new windows on this hell planet, one question is now burning in astronomers' minds. What other secrets are hidden in these brutally hot worlds, and how might these discoveries rewrite the story of planet formation in our galaxy? Stay with us as we dive deeper into the mysteries unraveling on WASP 121b and what they could mean for the future of planetary science. Looking ahead, the discovery on WASP 121b opens up a whole new realm of possibilities and some fascinating mysteries. If a planet can endure such intense heat that minerals and metals literally become vapor, what other surprises might lurk in the atmospheres of exoplanets across our galaxy? Scientists are eager to use the James Webb Space Telescope for even more detailed atmospheric modeling and high-resolution spectroscopy, not just for WASP 121b, but for hundreds of other extreme worlds. The hope is that by tracing how elements like silicon, oxygen, and carbon behave under these hellish conditions, we might uncover the hidden rules that govern how all planetary systems form and change over time. But there are risks and unknowns too. WASP 121b's atmosphere is actively escaping into space, forming a giant comet-like tail. This means that, over millions of years, the planet could shrink or even vanish entirely. If migration and atmospheric loss are common for hot Jupiter-type planets, could this explain why our own solar system's gas giants ended up in stable, cooler orbits? Dr. Vivian Parmentier, an astrophysicist at the Observatoire de la Côte d'Azur, said, "These findings highlight the potential of JWST to uncover new aspects of exoplanet atmospheres. We may be just scratching the surface." So what are the practical takeaways for us, watching from a safe distance here on Earth? First, the detection of vaporized silicon monoxide teaches us that planetary atmospheres are far more dynamic and diverse than we ever imagined. This fundamentally changes how we hunt for planets that could host life or valuable resources. By understanding the processes that shred or transform atmospheres, we can refine our search for worlds with the right conditions for biology or for future mining and exploration. Even more intriguingly, the technology developed for such discoveries is already feeding back into Earth-based industries. For example, the way silicon monoxide is detected and analyzed could lead to new sensors for solar panels or batteries, inspired by extraterrestrial chemistry. Astronomer Joanna Barstow from the Open University put it this way: "Studying the chemistry of ultra-hot planets like WASP 121b helps us to understand how gas giant atmospheres work under extreme temperature conditions, and pushes the limits of what we think is possible." So, what have we really learned from this so-called hell planet? WASP 121b has revealed that planets are not static. They evolve, migrate, and sometimes self-destruct in spectacular fashion. Each time we catch a glimpse of a molecule like silicon monoxide where it should not exist, we gain a new clue to the puzzle of how worlds are born and how they die. The more we push the boundaries of what we can measure, the closer we get to answering the big questions about our own origins and our place in the cosmos. And here's a little-known twist. The intense conditions on WASP 121b could actually help us model and predict the fates of other planets, including those much closer to home, orbiting sun-like stars. What we learn from this distant inferno might one day help us protect our own atmosphere, or even terraform new ones, as humanity ventures farther out into space. If you found this journey through WASP 121b's atmosphere as mind-blowing as we did, don't forget to like this video, subscribe, and hit the bell for more stories at the frontier of science and technology. And let us know in the comments, what do you think is the wildest possibility waiting in the atmospheres of other worlds? Until next time, keep looking up.